right, hello and welcome to the first video for 6.1 Radians. As mentioned, we are starting a chapter on trigonometry. We are continuing with our study of triangles, which sounds a little weird because the first shape you see in this note packet is actually not a triangle. The first shape you see is a circle. Okay, so we're actually going to combine two ideas here. We're going to look at something called the unit circle and how it relates to the study of triangles. All right. The very first part of this chapter, though, we have to talk about what is a radian. We can't do really anything with circles and trigonometry until we know what a radian is. All right. On the up there on the top underneath your vocab box there, you see a nice fun website called mathisfun.com, which it is. So we're going to head over there now, mathisfun.com. If you would like to join us there, you're more than welcome to. But this is what happens when you pull up that website. And it beautifully explains what a radian is. A radian is the distance around a circle that is the length of the radius. Okay, so recall that a radius right here is the distance from the center of a circle to the edge of the circle, right? It's what we use to draw the circle. Here we could say radius, I don't know, it kind of looks like 2 inches. We could say it's 2 inches. And so what a radian is in that same circle, it's the 2 inches along the circumference. It's the same measurement. If we go down here, it's a nice little video blurb for you. What is a radius? See how they've taken the radius and laid it upon the circle itself to create 1 radian. So that's a beautiful little illustration. I think it's great. How many degrees is a radian? It's about 57-ish, a little bit more. Not really what we're concerned with. We're not really going to use that measurement. Instead, we're going to look more at this, another little illustration for you. If I had some radians and I went halfway across the circle, then we get 3 radians and a little bit more. One more time, we'll look at that. 1, 2, 3 radians and a little bit more. And so half of a circle is pi radians. Pi radians is equal to 180 degrees. And so we can see we're not really going to use a 1 radian to degree measure. We're actually going to use a pi radians to half a circle measure, or 180 degrees. So I'm going to go ahead and go back to the note packet now, because right here, that's really important. We're going to go ahead and write that down. So we go back over to the note packet here. Once again, you see that same illustration. Here's that radius right there, right? And that same distance, radian. Now, how many radians are in a circle with radius 1? How many radians, we're not going to do that one. How many radians are in half of a circle? Well, we just saw that. There's going to be pi radians in half of in 180 degrees, or half a circle. We know that there is also 2 halves to a circle, right? And therefore there are 360 degrees to a circle. That's a throwback. But if you double that side, you got to double this side. And so there are 2 pi radians in a circle. There's 2 occurrences of this pi radians within 1 circle. All right. Now, if you take that circle and you further divide it, we have this circle up here, and we start dividing that pi in half. Actually, you know what? Let's draw a circle down here. We'll draw a fairly good circle. Okay. Here is that pi radians, right? The whole thing would be pi. If I cut that in half, I'm going to get pi over 2. Pi cut in half radians, right? If I do that again, I'm going to get pi cut in 4 radians. And we could keep going. We could have pi over 8, pi over 16, da 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 da. But we don't really talk about those. 2 others that we talk about is cutting it into thirds. And so we have pi over 3 and 2. Let's use a different color on that one just so we can see it a little bit. Sorry, okay. We're going to do brown. So if we cut that pi into thirds, we've got 2 thirds and 1/3 times by pi, right? We could do the same thing with 6. If we cut each of those thirds in half, we've got pi over 6, and then you've got 2 pi over 6, you've got 3 pi over 6, which is 1/2, pardon me, and then you've got, we don't need that line there, that would be 1/2. Sorry. And then we've got 2 pi over 3 again, and you've got 5 pi over 6, right? You can keep cutting these things in half. The ones we usually end up focusing on are these guys. You've got the pi over 2, pi over 3, pi over 4, pi over 6. We'll talk a little bit more in 6.2 where these relate in our unit circle, but that's what a radian is. Okay, a radian is pi radians to 180 degrees. A system we've been working with is degrees, so we need to learn now how to convert between radians and degrees. Let's go down to the exercises on page 3. 60 degrees. Well, let's give ourselves kind of a drawing of 60 degrees. I'd say 60 degrees is a little bit more than halfway, right? So something like that, 60 degrees-ish, right? That's starting to look like pi over 3. But I want to make sure I'm accurate, so 60 degrees, if I know that 180 degrees is equal to pi radians, and I want to take degrees and make it into a certain number of radians, then I'm going to divide by 180 to both sides. Basically, my unit conversion becomes pi over 180. This is not any different than trying to change feet to inches or miles to meters or anything like that. You have a conversion rate. In this case, our conversion rate is pi over 180. We want to get rid of the degrees, the 180. We want to get radians that have pi in them. Now, a little fraction math. I've got 60 and 180 dividing. I think I'm going to get 3. In fact, I was correct. 60 is the same thing as pi over 3. Cool, let's do that again. This time I have 72 degrees, not as clean cut as 60 degrees, so I might not draw it this time. But no matter what degrees I have, the conversion rate is the same. Just like no matter how many feet I have, changing it to inches will always be timesing by 12. In this case, changing to radians will always be timesing by pi over 180. So I'll go ahead and do that now. I can't really straight up straight up divide this, but I can reduce it a little bit. I see that they are both even. What happens when I divide by 2? I'd get 36 and 180. I'm sorry, 36 and 90. I can divide by 9 now, and I get 4 and 10. Maybe divide once more. We get 2 and 5. And so it looks like 72 degrees is the same thing as 2 pi over 5 radians. Sweet, let's do it again. We got the same conversion factor. I noticed that 10 goes into both of them and not much else. 23 is a prime number after that, so 23 pi over 18 radians is what I get out of 230 degrees. I highly recommend you try these last 3 on your own, see if you can find them, and then come back and see if you get the right answers. All right, hopefully you had time to pause the video. If not, that's okay. So divide by 180 here. Gives you pi over 10 radians. Over here, we've got pi over 180, and dividing that, I see a factor of maybe 60 or 10. We could start with 10. And then 6, so 5 and 3. Looks like 5/3. 5 pi over 3 radians. And last but not least, pi over 180. That just divides out to 2. And in this last one, recall that a full circle is 360. And so once again, with the conversion factor, we see that a full circle is also 2 pi. All right. Now, while it's important to take radians and get degrees, it is also important to take, it is important to get degrees and get radians, but it is also important to take radians and get degrees. And so we're going to go the other way around now. Here we have pi radians, and we want some degrees. Well, this one is actually the conversion factor. We know that pi is 180 degrees. The pi is the half the circle. And so we don't need to do any actual math on this one. It's as saying as if I had 1 foot. How many inches do I have, right? But this is going to help us with the next problem. In the next problem, we have 3 pi over 2 radians. And so since I want the radians to convert degrees, I kind of want pi to go away this time. And so I'm going to divide by pi, and my conversion factor is going to be the opposite of what we were using before, because we're also going the opposite way, right? We're going from radians to degrees this time. So instead of using pi over 180, I'm going to use 180 over pi. And then the pi's will cancel. No more pi's. I could reduce these guys a little bit. I get 90. 90 times the 3 that's left over, would be 270 degrees. So 3 pi over 2 radians is equal to 270 degrees. All right, this next one, I can do the same thing. I can do 180 over pi. Those guys cancel. Nothing to cancel underneath here except 1. So 180 times 3, I think it's 540, right? Because 18 times 3 would be 54. I could also kind of logic my way to this one. If 2 pi is a full circle, then 3 pi would be a circle and a half, and that would be 360 and 180 degrees, also 540 degrees. So you could logic your way to that one as well. But the conversion factors you saw, kind of convenient for us. All right, once again, I recommend you try these last 3 on your own, and if you want to do that, go ahead and pause the video now. All right, hopefully you had a chance to pause the video. Now we will do it we'll all do it together. So times by 180 over pi, cancel, cancel. 180 does end in 0, so I know it divides by 5. I'm just not sure into what. 36. And then 36 times 7, we get 252 degrees. Once again, timesing by that same conversion factor. Get rid of the pi's. 180 does that divide by 4. Interesting, it does. It gets me down to 45. 45 times 3 is 135 degrees. And last but not least, once again, 180 over pi. Pardon me, that should have been a 0. Pi's cancel. 3 goes into 18, and so 3 will definitely go into 180. We'll get 60 here. And it looks like we have 480 degrees, which is okay. It just means we're over a circle again. All right. That is how you convert degrees to radians and radians back into degrees. In the next video, we'll talk about rationalizing fractions, something else we're going to need for the unit circle. See you there.